In this example, we're going to acquire and decode some CAN data. CAN stands for Controller Area Network and was a bus invented by Bosch in the early 1980s for automobile applications. The CAN system is a differential system, so here we see channel A and B, the high and low of the differential system, being acquired. So now we can go ahead and set up the decode menu. So this is under the serial decoding, and here we can see the channels A and B. So we can select channel A as the high CAN and channel B as the low CAN signal, and then we can set up the parameters of each. So we've got the threshold, and we've set up the baud rate. So this system is 20 kilobaud, and we can set where the data is to be viewed. So at present we're viewing it in the acquisition window, and this is the record size recommended. So at present it's 1 million samples, and we can reduce it to a minimum of 5 kilosamples. So I'll reduce the record length to keep the update very fast. So I'm going to reduce it to 70 kilosamples, and here straight away we see the data being decoded. I'll change the acquisition to single shot, and we can acquire data and then decode it. So here we see the decode of the high and the low side, and again it's important to check that these are exactly the same. So I'll change the view now to a separate window. So again, for the high I'm going to unselect the in the acquisition window and select a separate window, and similarly for the CAN low and select a separate window. Okay. So here we can see the decode for the high side, and here we can see the decode for the low side. So again we can select some more data bytes, make an acquisition. So now we're decoding a lot more data on both the CAN high and CAN low. So again here we can see the sequence number, and here the unique ID. So this is a unique ID number for each data type. And then we can see all the information about the decoded bus, and here's the data bursts. The toolbar is the same as was described in the initial decoding section.